you have to pay attention if the circuit consists of the current source. As shown in this diagram, you can see that you have a current source in the circuit. The circuit is on the branch, so it will divide it into two types of circuit equation, which is the first will be the supermesh. If the currents at the outermost boundary of the circuits, it will become another equation, which is the mesh current is equal to the branch currents. As shown in this diagram, you can see that the blue color and the green color. The supermesh exists in the circuit if the current source is in between the loop. So this is the current source in between the loop. But if the current source at the outermost boundary of the circuit, for example, at the left side or at the right side, and then that source is not sharing the loopings with other source, it will become another equation. As for example, if the circuit is supermesh, you can see that there is a current source in between the loop, which is the left is the blue color and then the right is the green color. If the circuit consists of the supermesh, what you have to do is you have to do the KVL at supernodes, and then you have to do the supernode equation. So there will be two equations that related to the supermesh. Okay, so you have to combine the left circuits or the left loop and the green loop in order to do the KVL at supermesh. You can see here you still have the loop I1 and then the loop I2, but then you have to combine the voltage for all the elements for the left and the right loop. For example, you have to find the voltage here, 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 and here. So in order to do the KVL at supermesh, first is you are considering the current flow or the looping currents that flowing through the element. So minus Vs, you can see that for the I1 is flowing through the R1 here. So the polarity will be plus minus in here. And then for the green loop, the current is flowing through the R2, which is the polarity will be like this one. And then do the KVL at supernode, which is you are combining the voltage at the left and the right of the circuit. So minus Vs, you can see that minus Vs plus with currents I1 times with the R1 here. I1, R1 plus with the I2, R2 plus with the I2, I3 and then equal to 0. This is the KVL equation. And then for the supernode equation, what it is Is? You can see that the I1 is flowing through the Is and also the I2 is flowing through the Is. In order to do the equation for the supernode, you have to see that which is the same direction with the Is, and you can see that the Is is same direction with the I2, so it means that I2 minus I1 for the super mesh. This is the example on how to determine the equations of the supermesh. So as you can see that, take a look at the first current source, which is the purple color. And you can see that there is a loop I1 and the loop I2 with the different direction. In order to determine the Ix, you can see that the I2 have a same direction with the Ix. So it means that I2 minus Ix. And then for the blue color, Iy. Okay. So Iy have a same direction with the I1. So I1 will be minus with the I2. You can see that the arrows of the directions. As for the tip, if you see there is a resistor in the branch with the current source that look like this one. Yeah. So the current flow through the branch is Ix. Therefore, R is ignored or act as a short circuit. But then, of course, there is a V at the R. Because in mesh, we want to know the currents at the branch. If the branch is already give you the currents value, no need to do the equations of the KVL.